Number 3, we're asked to graph the quadratic. And if you look at the form that it's in, I see that it's in vertex form. That's great because for vertex form, it's really easy to pull out the vertex. So for vertex form, the x-coordinate is always the opposite sign of what's inside the parentheses. So if it's a -3, the x-coordinate is a +3. And the y-coordinate is always that back number, -1. You don't change the sign of the y-coordinate. So 3, -1 is a vertex. Axis of symmetry should be really easy. The axis of symmetry is always the x-coordinate of the vertex. So that's 3. We already found that. And then last but not least, finding the roots or zeros. You can actually do this by graphing the quadratic. So the first thing I'm going to do is plot 3, -1. And then from here, because this is representing a transformation, I'm really just graphing the parent function, just transferred 3 units to the right and 1 unit down. So for the parent function, I know that after you plot the vertex, you go to the right one, up 1, and plot a point, and then to the left one, up 1, and plot a point. So I just found the 2 zeros because this is where it crosses the x-axis. So my first 0, it crosses at 2, so x equals 2 would be 1, 0. And then the other 0, it crossed at 4. If you want to keep graphing and make it a little more accurate, after you plot 1, 1, the next coordinate of the parent function would be 2, 4. So you go to the right 2 from the vertex and then up 4. And then from the vertex, instead of to the right 2 up 4, you go to the left 2 up 4. And I'm going to connect my points here. And if you want to visualize the axis of symmetry, it's that vertical line that cuts the parabola in half. That was at x equals 3. So I'm going to draw a little dashed line to represent our axis of symmetry. And remember, the axis of symmetry can be used to plot points. Every coordinate from the axis of symmetry is a reflection. So if you're from the axis of symmetry, 2 units to the right, you would be 2 units to the left as well.